Statistic 1, Chapter 1 for Cambridge A-Level Mathematics, Introduction to Statistical Thinking, and this will be Chapter 1 full course walkthrough. It is a lovely presentation and arrangement by Dr. James Nicholson. Dr. James Nicholson is writing for Cambridge International A-Level Mathematics, both pure math and statistics. Again, the chapter overview will be looking at introduction to statistical thinking. We'll look at how we can describe the role of statistics in modern society, identify types of data. Data can either be primary data or secondary data. We can either also look at qualitative data, that is in terms of categorical data, or maybe numerical quantitative, because data can either be quantitative or qualitative. If it is qualitative, we can categorize that data, so we can now look at it in terms of categories. And if it is quantitative, we can look at it in terms of numerical values. It can either be discrete or maybe continuous data. And what exactly is statistics, and why is this statistics very important? So these are things we are going to cover in this particular topic. Statistical data have been recorded for most of the time civilization has existed. So the Romans gathered a lot of information on the population size and wealth of nations in their empire. They usually carried out a census every 5 years, which requires citizens to register their duties and property. So this was then used to calculate taxes. Modern statistics, which attempt to do more than just record information, dates back to the 17th century. So statistics generally is very important, and we are going to see how statistics now help us to deal with modern society problems. Now look at this body temperature measurement. Look at the two of them. As you can see, we have as we try to answer the question, what is statistics and why statistics is important. We live most of our lives relying on maybe only partial information to make decisions, right? So sometimes we rely on partial information that aid our decisions, isn't it true? So some of the information we use can be numerical, meaning it can be assigned value, it can be assigned numbers. Other information can be summarized numerically. We can either use numbers to summarize whatever information we have. So as we don't often have access to all the information when making decisions, statistics is largely about trying to make the best use of the data we have at any given time. If we have a better understanding of the information we have available, it will help us to make better decisions. So generally, statistics help us to make better decisions because we have a better understanding of the risk involved in the decisions we make. So if you consider this first graph, this graph shows the body of temperature reading for 20 people. Each person had their temperature taken with a mouth, let's say is orally taken, and maybe with an ear thermometer called tympanometer. So if it is using oral to measure this and take these readings, we can notice here that for each person there are variations between the oral readings and the thermometer readings. So though they claim to be testing the same value, but there are variations. And if you look at the second graph, it shows again the temperature of the same 20 people, But now the gender of each person is identified. That's why we can have male and we can have female. So the gender of each of them is identified. So we see that there is even more variability. It appears that male and females may have different body temperature characteristics. So we are surrounded by variations. Essentially, the unpredictability of life help us now to use statistics in order to make right and better decisions. So statistics is a tool for helping us to make a sense of the partial information that we have available and make more informed decisions. We already do this naturally and informally in many everyday situations, and that's why it is very important that we pay attention to details when it comes to statistics, because statistics will guide you through it, not just in your dealing with people, but also to inform the decisions that you make in order to have a better understanding of why you do most of the things that you do. So let's take some examples in terms of these statistics and see how they are important and they inform our decision in day-to-day life. So the first example we have, the insurance industry is based on a business contract that is beneficial to both the individual and the company. Why do we have insurance? Pause on it. That is a question that I want all of us to answer. Why do we have insurance? You can see a damaged vehicle below that. We say that insurance industry is based on a business contract, right? That is beneficial to both the individual and that of the company. But why do we have insurance? Now, it is good for us to have insurance, right? It is good for us. It is a big loss, may be unlikely to happen, right? If we talk about having insurance, let's say if a big loss is likely to happen, we couldn't afford it, right? We couldn't afford that loss. So it is good for the insurance companies as well. The large number of premium they take, maybe if they have a large number of premium that they take in, they may pay for the small number of the claims made, which means they will make a profit, right? So it means the insurance company may make a profit and the individual person that is insured may also be advantageous, right? But insurance involves uncertainty for both parties. Statistics can be used to calculate the potential risk and reward that is involved in both cases. So when we are asked this question, we can say that it is good for both of us, right? So if we write that down, so we can say that it is good. It is good for us, right? It is good for us in times of a big loss, right? So when you have a big loss, you will be covered by this insurance company. It is also good for the company because maybe they have a large number of people who are insured and there are just a small claims. So in this small claim, insurance company will also make profit. But insurance involves uncertainty for both the company and the individual. So statistics now will help us to calculate the potential risk and the reward that is going to be involved in terms of this type of thing. So this is one of the real life situations where statistics can be applied. An elevator should have a safety notice given the number of people and the weight it is able to accommodate safely. how should the company who makes the elevator calculate this? If we are looking at this elevator, this is an elevator that should have a safety notice given the number of people and the weight it is able to accommodate. So now, how do you calculate this? How do you calculate this? Again, the number of people allowed in the elevator at one point or at one time is only a proxy. So that number is only going to be a proxy, right? So if that number is a proxy for the important variable, the total weight, we can say that the company who makes the elevator will have to assume an average weight for each person. So all these are assumptions of the average weight of each person. Their weight could vary dramatically, right? The reality is that all mathematics of combining distribution depends on assumption of independence, and we must keep the presence of variation in mind. So it is important for us to know that even as we make this assumption, there are variations at some time. So this idea of a proxy is a key in medical tests. You should know the idea of a proxy is a key in a medical test. For example, where measuring is very expensive or maybe requires invasive surgery, if something else is found to be closely associated and easily to be measured, then that is often measured instead. That is a proxy. It is often measured instead. A proxy, it takes variations. So we should be able to know the reasons why we do most of the things that we do. And this is the reason why statistics is very important. And this idea of understanding what exactly is the aim of statistics will help you to pay more attention now as we dive into more calculations and looking at different types of data and how those data can help us in our day-to-day life. This is exercise. Consider the following situation where there may be a considerable degree of variation. Why is it a knockout competition? So here we have, why is a knockout competition much more likely to produce a surprise winner, than an extended league format? Why? I have included a table, and in this table I want you to tell me why. We have knockout competition, player A, player B, player C, and player D, and there is a winner. So the knockout competition may produce a winner, but does this mean that they are statistically the best player? Does it mean that they are statistically the best player? Answer me that. So ideally, when I think about it, when I think about the answer that could be given in this case that we have, why a knockout competition is much likely to produce a surprise winner, right? It's because we can think about it in terms of long-term form players. So long-term form plays an important part in an extended league format, right? It plays an important part in an extended league format. However, a surprise result in a knockout tournament can be caused by a temporary lack of form or from a team playing above their normal standard. And we see this in terms of even normal competitions. I know most of you guys watch football, maybe Premier League or La Liga, or maybe all this Serie A, all these games. There is possibility that a better team will be beaten, not because they are not good, but maybe they are out of form. So these are things we can consider. We can say that they lack form at a particular point, or from a team playing above their normal standard. So if a team who plays well play below their normal standard, it means that there is likelihood that they will be beaten. So this is something we must pay attention to. Number two, we have a whole large firm that has to quote a price for a job in which one of the major costs is the length of time the journey will take. They have to quote in advance, sometimes quite a long time in advance, but don't know how long the journey will take until it happens. What advice would you give to them? What advice would you give to them? Well, if you ask me what advice, I would say either collect or use previously recorded data to estimate the travel times for the journey involved. Right, because you must be able to look at what has happened before and predict what is likely to happen. The likelihood of what is going to happen depends on what has already happened. And later on in statistics, when we will be looking at probability, we will be looking at the likelihood of something to happen, or by looking at what has already happened. Given that this happened before, then we can actually predict what could happen. So for us to predict what could happen, we have to go back to history lane by looking at what already happened. So my advice would be either collect or use previously recorded data to estimate the travel times for the journey involved. And whenever you are given this type of question in exam, it is an open-minded. That's why it is introduction to statistical thinking. You are allowed to think as a person. You are allowed to reason and see what could happen. So the answer to this particular question is open to your thinking, and it is acceptable depending on how you reason, but you must be able to reason statistically. Number three, the government are to set up an inquiry into health and safety issues relating to the positioning and operation of mobile phone transmitters. What factors should they be looking at? When you ask me now, what factors should the government be looking at? I would say there is extensive research that was carried out by bodies like the World Health Organizations, right? There is such organization who into this particular question. Unfortunately, much of this information is often inconclusive, and the outcome can also be confused by report from interested parties such as the mobile phone providers. So this is what I would say. So there are so many factors involved, and if people give inconclusive information, then there is possibility that the final conclusion you arrive is not correct. And that is why now we need more statistical way of handling such problems. Types of data. Types of data. We have different types of data. Data can either be quantitative or qualitative. When data is quantitative, it takes a numerical value. When data is qualitative, it is non-numerical. Now, categorical data are data which can be divided into distinct categories. So we can see it as either qualitative or quantitative. So you can see sometimes we can refer to qualitative data as categorical data, because we want to see and look at distinct categories of this data. And later on, we will proceed to classify this data as either discrete data or maybe continuous data. Look at the fruit on this trader's stall. It can be described by its properties. So we can look at these fruits on the trader's store and try to describe the properties of those fruits. Just look at it and tell me how you could describe that. So we can start by looking at the type of fruit. So the type of fruit, important. The type of fruit, right? So if we look at the type of fruit, we can look at as well the color. The color. We can look at how ripe is it. How ripe is it? And these are qualitative data. They are non-numerical. These are qualitative. This is qualitative. Qualitative. Right. Non-numerical, categorical data. Again, we can look at the fruit in terms of the number of that fruit. When we look at it in terms of the number, we can look at the fruit in terms of the type of fruit it is, the weight of a piece of it. So we can look at it in terms of the weight. So if we look at it in terms of the weight, if we look at it in terms of the cost of the fruit, then all this becomes quantitative. They will take numerical values. So again, we can say we have two types of quantitative data. Quantitative data can either be discrete, limited to particular values, or continuous, any value within the range. So the number of pieces of fruit can only be one of a list of values. It can be 0, 1 through. For example, these 5 oranges that you can see are an example of discrete data. So the weight of the oranges can be read from the scale as maybe 1400 grams. If you measure it more exactly, however, you might find it is less than 1400. It can be 1396.2 grams. So maybe 1 decimal places, or it can even be more than that. So this is an example of continuous data. It will always be reported as a rounded value. What data about the radio are given in the advertisement? For which piece of data state whether it is qualitative or quantitative. If quantitative, whether it is discrete or continuous. Now let's look at what the data that we are given. These are different data. We have the power output. So the power, these are the data that we have. Data, power can be seen in terms of quality, or quantity. So this is 2 by 2 watts. So this is quantitative and continuous. Wave bound Wave bound is qualitative. It doesn't give us numerical value. Dimensions here, we can look at the number of batteries that is given. That is the dimension 25 centimeter by 20 centimeter by 5 centimeter. So this number of batteries needed is quantitative and discrete. Quantitative and discrete. It gives a numerical value. The price as indicated at $9.9 is quantitative and discrete because it gives us a numerical value. The color, as we can see, is qualitative, available in black or silver. Qualitative. The length, we can talk about the length, the width, the height, 4 by A batteries, mains by batteries. We are looking at the length, we look at the height, the width. These are quantitative and continuous. So for a large number of data observations, a list is not easy to make sense. And this brings us now to the idea of frequency table. So a frequency table of values can be used to summarize a large list. Sometimes it is helpful to use groups of values so the data are more easily understood. Example, a group of 45 women go on a skiing holiday. Summarize the following data in frequency table. So we have the first data, and then we have the second data. The number of children each woman has, the women's age, use class interval of 15 to 19, 20 to 24, etc. to make that interval. So let's look at, we could make a table. So the first table here will represent a group of 45 women that go on a skiing holiday. We want to summarize the following data in that table. So for us to be able to do that, we can tally whatever we have. We can tally the information, the data given. How many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 of that. So it means here we can say this is number of children. And here will be the frequency. So for 0, we have 12 women have no children, right? So we have 12 women have no children, 21 women has only 1, 8 has 2, 3 has 3, none of them has 4, and 1 has 5. And it becomes very easy for us to read. Now let's go back to the second question. The women age is like, we are going to use the class interval 15 to 19, 20 to 24, 45 to 49, and tally that. So we are supposed to start from 15 to 19. So 15 to 19, we can try to count 15 to 19. 17 is within that interval. We have 15, 17, this is 2 of that. 19 is here, 17. Which are the value? 19 is here. So how many I did? 1, 2, 3, 4, 5. 5, check well. 22, 26, 48, 26, 28, 29, 19. Yeah, so we have 1, 2, 3, 4, 5, 6. So the interval 15 to 19 is 6 of them. So this can represent the age, and this is the frequency F. So 15 to 19 is 6 of them. And we can have now 20 to 24. 20 to 24 will be how many of them? 20 to 24, 1. So we have 1 there, 2, 3, 4, 5, 6. Is it 6 of them? 20 to 24. Always cross check. There is 23 here, so it is 7 of them. So 20 to 24, 7. The next becomes 25 to 29. 25 to 29 is, we check again, 25 to 29, 1, 2, 3, 4, 5, 6, 24. Then we have 25, this is 6, to 29, 7, 8, 9, 10, 11, 12, 13, 14 here, 25 to 29, 15. So it is total of 15. 25 to 29, total of 15. So we have 15 of them. Then 30 to 34, we have 30 to 34, this be 35 to 39, and then 40, 30 to 34, 35 to 39. We will have also 40 to 44, and then 45 to 49. 45 to 49. And when you tally all of these, you should be able to get 15, 6, 8, 1, and then 2, by making sure that you have tallied all the data given in this question. Let's look at example 5. Consider the marina at Mount Carlo. List at least 4 pieces of relevant data that might be collected. Include the type of data and how it may be collected. If we want to look at this data and look at that image carefully, we can look at so many examples that could be collected for this situation. And we can include even the number of boats in the marina at any time, which is quantitative or discrete. So I can say that the color is important. The color. So if we look at the color, sorry about that. So we will look at the color, and the color is going to be qualitative. qualitative. We can as well look at the length. The length is going to take quantitative, and so it is quantitative because it takes numerical value, and it is also continuous. We can as well look at the age. The age of the bolt in years is going to be quantitative. We can even look at the name, and we can as well look at the value. So there are so many things that could be considered here, but these are just some of them. Now, what exactly is primary data? We have two types of data, primary and secondary data. Primary data is any data which you collect yourself. It may be measurement, but can also be through questionnaires or other surveys, investigations, and experiments. Secondary data has been collected by someone else other than the person using the data. That's why it is secondary data. It may be in the form of the raw data, but it also includes the databases, published statistics, and the newspaper, or maybe more than that. Look at this example. Amma is concerned about the traffic passing his house. One morning, he spent an hour counting the cars that passed his house. He then hears that the council have installed a sensor which automatically registers when a car goes by. Amma gets a summary of the traffic in the past 6 months from the council. Now, the first set of data described is primary data. This question, I wanted you to know what types of data it is. The first set of data described is primary data because Amma collected it himself, right? The second set is secondary data because it was collected by someone else, the council. The council have installed a sensor that automatically registers that, so it becomes a secondary data, right? It is a secondary data. It is collected by someone else, the council, in a digital logging process. Test your understanding. Test your understanding on what you have learned so far in terms of the introduction of statistics. So basically, this is an overview to prepare your mind on what we are going to deal with in terms of statistics. So in the next video now, which will be chapter 2, we will do measures of locations and measures of spread. Measures of locations and measures of spread, where we are going to look at measures of central tendencies like the mean, the median, the mode. We will also look at variations like ranges, interquartile ranges, the standard deviations, how to calculate the mean and the standard deviation of a set of data, and how to use a frequency distribution table. So we look at averages among other things. So it is now we are entering into recalculations of statistics. The idea of statistical thinking is to help prepare your mind on what to expect in the overall topic. So in chapter 2, we will start now looking at the measures of spread and the measures of locations.